shape, their composition, magnificent, right? Even the way they move, truly fascinating. But have you ever wondered why they move in this manner? Like how?
The fascinating movement of planets can be explained by Johann Kepler's law of planetary motion, and this is how it goes.
In the early 1600s, Johann Kepler proposed 3 laws of planetary motion. Kepler was able to summarize carefully the collected data of his mentor, Tycho Brahe, with 3 statements that describe the motion of planets in a sun-centered solar system. Kepler's 3 laws of planetary motion can be described as follows: the law of ellipses, equal areas, and harmonies.
The path of the planets around the Sun is an elliptical shape, with the Sun being located at one focus.
While the second law is about an imaginary line drawn from the center of the Sun to the center of the planet, sweep out equal areas in equal intervals of time.
The ratio of the squares of the revolutionary periods for 2 planets is equal to the ratio of the cubes of their semi-major axis. T square is directly proportional to r cube. So, T square by r cube is equal to Kepler's constant.
Great! So now, we already know what law governs the planetary motion. But I wonder where gravity is. It has not mentioned earlier. So, how does the great gravity affects the planetary motion?
But first, what is Newton's law of universal gravitation?
Every object in the universe attracts every other object with a force that is directly proportional to the product of the masses of the 2 objects, and inversely proportional to the square of the distance between the centers of the 2 objects, and in a line connecting their centers.
Gravitation is saying is that when the net force acting on an object comes from gravity, the acceleration is equal to the mass of the bigger object, like Earth, divided by the distance between the 2 objects times small g is actually equal to big G times Earth's mass divided by Earth's radius squared. Newton's law of universal gravitation, we know that the acceleration of stuff at Mars' surface would be equal to big G times the mass of Mars divided by Mars's radius squared. We also happen to know Mars's mass and radius already, which helps. So plugging in the numbers, we can calculate the gravitational acceleration at Mars's surface. It should be about 3.7 meters per second squared.
Now you know why how things move in space. Next time, we'll
Objects
think
allowed to be established that
and you want to